This video we're going to be looking at a fairly tricky example that should remind you to pay attention to what the rate limiting step is in radical halogenation processes. So we are going to be reacting propane with an equimolar mixture of bromine and chlorine. That's diatomic bromine and diatomic chlorine. We're going to be either heating that mixture or irradiating it, and we get a mixture of chlorination product and bromination product. We'll actually get more chlorination product because alkanes are more reactive to chlorination than they are to bromination. But when we look at the bromination product, this is the product distribution that results. And this should be surprising, given that in bromination, secondary reaction with substitution of a secondary hydrogen, like the hydrogens here, are favored over substitution of a primary hydrogen, like the hydrogens here. We also have 3 here. The substitution of secondary hydrogens is favored over primary hydrogens 80-1. So I'll just make a note of that here. Favored for primary 80-1. And yet you seem to get 57% secondary product and 43% primary product. Well, does it have to do with the number of hydrogens? Well, let's look here. Well, you have 2 secondary hydrogens whose abstraction leads to this. So 80 times 2, that's 160. And you'd have 6 primary hydrogens whose abstraction leads to this. So 1 times 6 is 6. And if we add 160 and 6, we get 166. So 160 plus 6 equals 166. We divide 160 by 166, so let's say 160 by 166. We get something like, let's see, what is that? This is about 96%, which would make this about 4%. But our product distribution is 57 and 43, not 96 and 4. So what's going on here? We are getting a whole lot more primary product than we should. And what happened here is this is actually, even though this is bromination, this is the distribution you'd expect for chlorination products. Because remember, in chlorination, the selectivity, so this is bromination, so Br. For chlorination, secondary hydrogen is favored over primary only 4-1, approximately 4-1. So here, if you multiply 4 times 2, you get 8. So this is, I'm just going to say secondary product. 4 times 2 is 8. And you have 6 primary hydrogens whose abstraction would lead to this product. So these 3 on this carbon and the 3 on this carbon. So, and that relative reactivity is 1. 1 times 3 is 3. Or sorry, 1 times 6 is 6. So this would be 8/14. And of course, that's 57%. And this would be 6/14. This is about 43%. So it does seem like even though these are bromination products, they appear with the distribution you'd expect for chlorination products. Remember, we also have chlorination products forming, but we're not considering them here. So we're just looking at the bromination products. So why is this? Why do you have a mixture of bromination products that follows the relative ratios you'd expect for chlorination products? And to answer that, you really have to take a closer look at the mechanism. You have to recall the mechanism. So you have propane here with these two secondary hydrogens, 3 primary hydrogens on this carbon, 3 on this one. It's when you have an equimolar mixture of Br2 and Cl2. The Cl2 is going to be the more likely to abstract. Remember, Cl2, chlorine is both of these. Like this will furnish bromine radical. This will furnish chlorine radical. But this chlorine radical is going to be the more likely abstractor, right? Chlorine is more reactive. So you are more likely to get abstraction by chlorine. You could have abstraction here, or you could alternatively, you could have abstraction here. Of course, I should draw this half arrow like so. But this is abstraction of a secondary hydrogen with chlorine is only 4 times more likely to occur, or as likely to occur as that of a primary hydrogen. So regardless of whether, when you have bromine and chlorine in the mixture, it's chlorine that's going to be doing the abstracting. The overwhelming majority of the time, it's so much stronger. So it's so much more reactive. So you'll get a mixture of secondary radical and primary radical here. And this mixture, this distribution will be 57-43. And that just falls out of this calculation here because there are 2 hydrogens, secondary hydrogens, that could be abstracted to give you the secondary radical. There are 6 primary hydrogens, equivalent primary hydrogens, that could be abstracted to give you the primary radical. If one of these hydrogens had been abstracted, you'd get this radical, but this radical is equivalent to this radical. So, okay, and we multiply by the relative reactivity. So the 2 that could be abstracted to give this relative reactivity to chlorination, abstraction by chlorine, I should say, is 4. So 2 times 4 is 8, and here you have 6 of these whose abstraction could lead to this, and the relative reactivity of primary is 1. 6 times 1 is 6, and so that's just this calculation here. And now remember, this is the rate limiting step here. This is the slow step of the reaction. So it is much more likely to proceed with chlorine than it is with bromine. And at this point, both reaction of diatomic bromine with each of these radicals, as well as reaction of diatomic chlorine with each of these radicals, are fast steps. So you are going to be getting, when you're just considering bromination, you're going to be getting that, and you are going to be getting that. Oh, oops. That in the same ratios as this, because you're going to have 57% 57% of the radicals floating around are going to be secondary radicals, and only 43% are going to be primary. So bromine attacks a radical, it's gonna be bumping into a secondary radical 57% of the time, so it'll give you a secondary product 57% of the time. Because here it'll give you a primary product 43% of the time. Now, if I'd asked you a similar question, right, like this same propane but instead of an equimolar mixture of bromine and chlorine, let's say it was an equimolar mixture of fluorine and Cl2. Well, fluorine is going to be the dominant hydrogen abstractor. So any chlorination product that's observed will be observed in the ratios that forms it. It's going to be in the ratios of fluorination, because fluorination is doing the abstracting. So you'll get this and this, but the ratios of product will follow fluorination. And remember, fluorination is not nearly as selective. So the chlorination product is going to be a lot closer to the statistical distribution. Okay, so hopefully that gives you some insight into why you should, or I shouldn't say some insight into why, but that hopefully reminds you to pay attention to what the rate limiting step in the reaction is. So when you see these types of problems, you make the right decision in terms of realizing which halogen is going to do the abstracting.